Today on How It's Made. Mobile concert stages. Mascara. Continuous miners. And wood gift boxes. The mobile concert stage was invented in Canada in the 1980s. It uses hydraulics to fold into a trailer for transport, and then unfolds upon arrival at the event venue. It takes 45 minutes for a crew to set up a mobile stage, and then it's showtime. No stage? No problem. Just order a mobile hydraulic stage, and in less than an hour, you're ready to rock and roll. The convenience means it has plenty of fans in the event production industry. A mobile stage starts with the trailer framework. A worker saws aluminum beams to length. At the same time, another member of the team pieces together aluminum tubing for the roof. He welds the joints to complete the roof skeleton. He then welds the trailer support structure together. With the girders assembled, the trailer substructure is ready for the axles and wheels. Each axle can support 10,000 pounds of weight. They install hydraulic cylinders on each corner of the trailer. These cylinders are the extendable legs that will stabilize the stage trailer on the ground. Next up is a panel with valves to control the flow of hydraulic fluid. They bolt the panel to the back of the trailer and connect hoses to the valves. This network of hoses will circulate fluid for the hydraulics. They cover the valves and hoses with a metal plate. The plate has slots for control levers. They screw the levers to the valves. He then installs a hydraulic pressure gauge. The team now lowers the tank for the hydraulic fluid into the base frame and secures it. They run the hoses for the hydraulic fluid through a filter at the entrance to the tank. They're ready for the extendable supports for the stage mast. Using a forklift, they maneuver the parts into place at the ends of the trailer. They return to the floor and bolt 6 hydraulic cylinders into the framework. They'll be used to lift and lower the floors. The roof structure is next. A crane does the lifting, and a worker guides the panels onto the beams. They secure the panels with hinges, torquing them tightly. The team transfers the floor panels to both sides of the main chassis. They install leg jacks to support them. There are 8 jacks for each floor panel. They install more hydraulic cylinders for raising and lowering the floor. This mobile concert stage is ready for the outer skin. An employee glues fiberglass sheeting to the sides. A team then lays the plywood floor sheet by sheet. The plywood is marine grade. It has a laminate composite surface. The laminate is textured for skid resistance. It's also waterproof for outdoor events. Once all the paneling is in place, this mobile stage is ready to go on tour. 8 weeks in the making, it will be a time saver on the road. One way to enhance eyelashes is to coat them with mascara. Early mascaras were made of petroleum jelly and coal, or soap cake tinted with black dye. Today's liquid mascara comes in a tube with an applicator brush built right into the cap. Mascara formulations vary. The basic ingredients are wax, water, pigment, and binders. Additional ingredients produce features such as water resistance. Every formulation is comprised of an oil-soluble phase and a water-soluble phase. To prepare this mascara's oil phase, a technician combines 4 types of wax: carnauba from a Brazilian palm tree, candelia from a plant that grows in parts of Mexico and Texas, beeswax, and glycerol stearate, an emulsifier which helps ingredients blend well. Next comes vitamin E, which conditions lashes and gives the mascara a smooth texture. After that is a chemical compound called Palomol D2000, which makes the mascara water resistant. The technician heats this oil phase of the formulation. Once the waxes begin melting, blends the ingredients. Wax is a thickener. This calculated combination of 4 different waxes produces a semi-liquid gel that coats lashes with a shiny film. The technician now prepares the water-soluble phase of the formulation separately. First, heating up cold water. Then adding an emulsifier. This will bind the water and oil phases when they're combined later on. Without an emulsifier, oil and water solubles would naturally separate. The next ingredient is a cosmetic-grade iron oxide pigment. The color is black because she's making black mascara. She blends the mixture until the color is uniform. Then she adds TEA. This organic compound balances the mascara's pH level so that it isn't too acidic or alkaline. Next, she adds a cosmetic powder to make the mascara silky and a chemical to provide additional water resistance. Finally, she completes the formulation by adding the oil phase to this water phase. Heating the mixture while blending prevents the waxes from solidifying. Before packaging, the factory's chemist runs quality control tests. Using a viscometer to measure thickness, he makes sure the mascara isn't runny or gooey. He also tests the pH level. If the sample meets specifications, the lab gives the go-ahead to package the mascara, and the worker pours the batch into a filling machine. The machine continuously mixes the mascara and keeps it hot so that it remains liquid. Otherwise, the mascara would begin to cool and gelify and clog the filling nozzle. A mascara bottle typically contains about 2 ounces of mascara. As it cools in the bottle, it transforms into a semi-liquid gel. She seals the bottle by pressing in a plunger-style plastic stopper. The stopper has a hole in the middle for inserting the brush applicator that's built into the bottle's cap. The lip of the stopper hole is designed to wipe off excess mascara as you pull the brush out of the bottle. This helps prevent the mascara from clumping. This manufacturer fills small orders manually, like this one for a private label brand. Its automated production line is reserved for large orders. Regardless of quantity, clients specify the characteristics they want in their brand of mascara, such as lengthening or water resistance. And the manufacturer tailors the formulation accordingly. The continuous miner is always on the job. This machine constantly bores into deposits of coal, salt, or potash to break them into little pieces. Its invention in America in the 1940s was an earth-shattering development. The continuous miner is a force to be reckoned with underground. A spinning drum spiked with tungsten carbide teeth. It tears into the rock face and spits the pieces out onto a conveyor. The continuous miner can remove 24 tons of minerals per minute. That's more than a human miner can dig in an entire day. The work is hard on the equipment, and so eventually, the continuous miner undergoes a complete rebuild. It starts with an extensive cleaning. After a steam wash, a worker aims a torch at the bolts of the drum. The heat causes the bolts to expand and move away from the hole. This makes it easier to pull them out using a pneumatic impact wrench. Once all the bolts have been removed, the drum can be pried from the shaft. Once free, a crane lifts the heavy drum, and workers guide it to the next station. Here, a worker in protective gear blasts the drum with tiny steel shot. This removes any remaining dirt and grime. Some parts, like these centrifugal loading arms, are beyond repair, so they build new ones. Connected to a hub, these arms will move mined material onto the machine's conveyor. A worker reinforces each one with a wear plate. He then heats the wear plate and loading arm before welding them together. Preheating reduces the possibility of the weld cracking. They lower the loading arm assembly into the machine framework. Then a computerized cutter carves a sheet of steel to make new access panels for the continuous miner. The slicing force comes from a pressurized mixture of water and garnet granules. No blade is necessary. The operator of the machine hoses off the filings. He retrieves the cut part with a magnet. Over to the conveyor part of the continuous miner now. They had built up the hole for the pivot pin because it had stretched from wear. A tool mills the built-up hole to return it to the correct diameter. The team then focuses on the main frames of the continuous miner. They weld the cracks and grind them smooth. Now, beginning with the conveyor tail, a worker spray paints the continuous miner one piece at a time. Another member of the team inserts new plugs into an electrical control box. He bolts the panel holding electrical controls to the machine casing. He then installs heavy doors that swing open so the electrical can be easily accessed. There are a total of 25 covers and doors on the continuous miner. Some protect hydraulic hoses, others encase the wiring or gearboxes. They can all be removed if maintenance needs to be performed. It's taken several months for this massive overhaul, and they're ready to put this rebuilt continuous miner to the test. Using the machine's remote control, a technician checks the function of every component. With his approval, the continuous miner goes back underground to pick up where it left off. A product presented in a beautiful, high-quality wooden box is sure to stand out. Companies use them as special event displays or as corporate gift boxes. Because they're handmade, the boxes can be customized to showcase each product. Wood gift boxes make wonderful cases for spirit bottles, collectible coins, watches, or Christmas ornaments. Not only do they display the product beautifully, they also protect the contents inside. Today, they're making a box with maple boards, which are cut on an automated saw. A mortiser's parallel blades cut square-shaped notches at the end of each plank. These will serve to finger joint the sides of the box later on. The pieces of wood are pressed against the corner so that the resulting fingers are perfectly aligned. The factory usually makes fingers that are 6 millimeters wide. Wider fingers would be unsightly, and thinner ones would be too fragile. They now prepare the top of the wood box. A press uses heat and pressure to stamp the company's logo on the surface of the wood. They brand the wood with a magnesium plate, heated to 840 degrees Fahrenheit. The process takes just 2 seconds. Next, they assemble the sides, interlocking the pieces manually. They use a rubber mallet to avoid damaging or denting the wood. When the 4 sides are end to end, they apply a small amount of wood glue on the inside of each joint. They form the corners at a 90-degree angle. Once the box is assembled, a press will finish pushing in the fingers on each joint. When the box comes out of the press, they check the square. They apply wood glue for the bottom of the box. Since the bottom is less visible, clients sometimes choose plywood instead of solid wood to save on cost. They glue a solid maple top, and the boxes go in a press for 35 minutes until the glue dries. After sanding, a router shapes the edge of the box's top. By changing the router bit, they can create all kinds of decorative profiles. This one is simply rounded. They sand the whole box again with 120 grit sandpaper and finish with 180 grit sandpaper. Now they can cut the box open starting at the back. They create a wide angle so the lid can open freely on its hinges. Next, they make a straight cut through each of the 3 remaining sides, sawing the box in half. They separate the body from the lid, and the two match up perfectly. Each half of the box goes on an automated milling machine called a slotter. It cuts the slots in the wood on the back of the box. These slots will receive the hinges. The bottom of each slot is rounded to cradle the rounded ends of the hinges. These hinges are made of nickel-plated metal. They're designed to be pressure-fitted, so they won't need any screws to stay in place. The worker uses a rubber mallet to insert the hinges in the body of the box. Once the hinges are aligned with the lid, he squeezes them tight, using the hammer again if necessary. The angled cut creates enough space for the hinges and helps to open the lid. They apply a coat of sealer, lightly sand the wood, and finish with a coat of lacquer. When the lacquer is dry, they install the magnetic closure in a pre-drilled hole. Another magnet goes into the lid, and that makes for a nice closing box. They stick a piece of self-adhesive felt to the bottom of the box and trim the excess. Next, they line the box with foam in order to protect its contents. Some clients prefer thermoformed plastic trays molded to their product-specific shape. You can choose the size, shape, type of wood, color, and hardware of the box. The only limit is your budget and your imagination. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.